What?
0 0
0 0
0 0 0 1 ma'am 3 0 1 0
Wait. 3 0
1
1
1 0 1
1 0 0. Did you get this?
0.
Did you get this,
Yes, ma'am.
everyone?
Yes,
That
ma'am.
is called as left shift. Everybody got it? This is left shift. Huh? Everybody got or not?
Yes, ma'am.
So that is a left shift L. So that's what they are telling. Now do right shift. Same thing. Can we do right shift now? Same thing we are going to take. Same thing. Do it for right shift. 5 only do right shift. That is L shift R. That is right shift. 7 comma -2. Do it. Do it. Right means how it will come. This side it should go, ma. Okay, 7. What is the binary number? Tell me. Binary number of 7 divided by 2. You do first.
111.
111. So 0 0 0 0 0 111. So when you are using the right shift, no, this it will be shifted like this side. From this side it should come. This 0 will go here. This 0 will go here. This 0 will come here. This 0 will go here. This 1 will come here. This 1 will come here. So what will be my answer?
111.
0 0 0 0 0 1 1. Got it?
Yes, ma'am.
So that is a right shift. Again, one more shift you do one more time. This is shift right.
Four zero 3 0 1.
That's all. 4 0 3 0 1. That's all. So everybody got it?
Yeah, ma'am.
Yeah, ma'am.
Next thing we are going to see. That's what same thing they are explaining. Okay, same thing. This program later I will explain, because now you will get confused. Later I will tell you how to pack the 2 binary digits using shift. Using shift L and this one. Next, rotate. What is a rotate? Rotate means what? Here one bit is getting lost. Instead of that, whatever last bit we are making, we will place in the carry, and that bit will rotate. That is called as rotate operation. See, in the shift operation, bit shifted out of the operand or lost, except for the last bit shifted out, which is retained the carry flag. To preserve all the bits, set of rotate instruction can be used. That is the main thing in the rotate operation. So rotate with carry, rotate without carry and all is done. Okay, so we are going to see rotate. See, rotate. This one is rotate. R means rotate right. Rotate with carry. Left with carry means rotate LC. Rotate left without carry means rotate L. Rotate right with carry means rotate RC. Like that you should remember. So now if I have giving bit, you with carry you have to rotate it. I'm going to one example I'll give now. Same thing, 5 only I will take. Rotate 2 times. #2. It is rotate LC. That is rotate left with carry 5, #2. So now what I should do? So 0, 0, 0, 0, 0, 1, 0, 1. Shift left and rotate. You know how to shift left. So 0, 1, 0, 1. See, one second. Now don't place anything here. In the first bit you leave off. Other thing, same thing you use it. This 1 will come here. So I'll place 1 here. This 0 will go here. 0. This 1 will come here. 1. This 0 will go here. 0. 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 What is a last bit? That is whichever is a loss, that will be placed in the carry flag. That it will be coming and placed it here like this. Got it? Got
Yes,
it?
ma'am.
So that is a shift. Rotate left with carry. Then now you rotate right. I'll tell you which one I should rotate. Understood now everyone?
Yes, ma'am.
Any doubts my ear? Rotate
No, ma'am.
RC 9, 3 times. #3. Do it. Who is doing LC? Fast. Only 10 minutes left. Make it fast.
From 0101, 4 zeros, ma'am.
What is the answer? 0, 1.
01, 4 zeros.
0, 1, 0, 1. Everybody got the same? Everybody got it? Same answer? Any doubts, ma? So that's what. Rotate left, rotate right. I'll give this one. Understood or not?
Yeah, ma'am.
Hello. Please answer.
Yes, ma'am.
So any doubts here? Rotate left, rotate R, shift left, shift R.
Ma'am, answer. Ma'am, 0 1 0 0 1 0 0.
0 1.
00.
He was telling 0 1 0 1. No, I'll only do then. Yes or no answer? Tell me properly, pa.
Ma'am, 0 1 0 0 1 0 0.
0 1 0 0.
1 0 0.
Got it? Got it, everyone? Everybody got it or not? Hello?
Ma'am, we should circulate the values 3 times, no, ma'am?
Yeah, circulate the value. See here. What is this one? 1001, I think, no? So 0 0. For 9, it is 1001 binary value. So rotate right 3 times. Right. So what I should do? Like this. So you first digit keep it as a blank. Then this 0 will come here. This 1 will come here. This 0 will go here. Then 0 will go here. What is coming out? That is 1. That will be rotated and place it in the first shift. This is the first shift. Then second shift. 0, 1,
Answer.
0, 0. Then this 0 will go here. Then 0, 1, 0. This 0 shifted out and place it as a first digit. 3 times you have to rotate. One more time I should do. 0, 0, 1, 0, 0, 0, 0, 1. Whatever is shifted here, it will be placed, but 0. Okay, got it? Since 0 is shift, same thing is placed. Got it?
Yeah, ma'am.
So what is the answer? What is the answer?
0010 0001.
Correct. This is wrong. 0, 0. What you told is wrong. 0, 0, 1, 0, 0, 0, 0, 1. Got it?
Yeah, ma'am.
Shall I start the next encoding of machine instruction? You're not at all responding today. Why? Any doubt, ma?
No
Tell
doubts,
me.
ma'am.
Hmm?
No
No,
doubts.
ma'am.
Okay. So tomorrow we'll see this one because already time only 5 minutes left, I think. Yeah, 3 minutes left. Next hour is whom? Next level is whose?
Maths, ma'am.
If you is going to take, then I'll continue. Can I continue for another 10-15 minutes? I'll put one more Zoom link. Hello. See, nobody will answer.
Okay, ma'am.
Yes or no?
Yes, ma'am.
Okay, ma'am.
Leave it anyway. Rishila ma'am? Hello? Hello? Are you able to hear me?
Yes, ma'am.
2 minutes, let them join. Hello? Can I start? Can I start, ma'am? Yes, ma'am.
Ma'am,
Can I start?
ma'am,
Tell me.
excuse me, ma'am.
Tell me, ma.
Ma'am, can you explain the shift and rotate operation again, ma'am? Ma'am, there was a network issue. I didn't understand anything, ma'am.
Okay, for you or many people, because for you means separately I will teach you. For all together means how many people didn't understand, ma? Anybody? Otherwise, you tell me. If majority are there, I'll teach you again. Otherwise, for her separately, I'll teach her. Okay. Okay. Anyway, I'll revise. Okay. Shift and rotate nothing, pa. See here. Suppose shift left. That is, there's an operation called two shift are there. Shift left, shift right. Okay. That is logical shift and arithmetic shift. So that's why L indicates logical shift. L shift. Usually logical shift only they will ask. L shift like this they will give 5 some number I'll take 1 second. 7 comma ash 2 like this if they give. Who is asked? Who asked? What is your name, ma?
Safina, ma'am.
Now you able to see the screen, ma?
Yeah, ma'am.
So now 7 you convert into binary. So 2 3s are 6, 1, 2 1s are 2, 1. So what is left? 1, 1, 1. Am I correct? See here 1, 1, 1. That you should write from LSB. Then I told you have to convert into 8 bits. Remaining thing you fill with the zeros. 0 0 0 0 0 1 1 1. Left shift is nothing but we are shifting like this. This one will come to the next position. This one will come to the next position. This one will come take the place of 0. So what happened? This one, if it come to the next position, here 1 will come. This one will come to the next position, 1 will come. This one will come to the next position, here 1 will come. This 0. So this 0 will come here. So this 0 will come here. This 0 will come here. This 0 will come here. So now whatever left that MSB will become 0. That's all. Now one more shift you do. One more time you do. Rafina, now you tell me.
0.
Yeah, 0 will come here. This 1 will
1.
go here.
Yeah. 1.
This 1 will come here.
0.
0, 0.
0.
So this will become 0 always. Understood?
Yes, ma'am.
Got it?
Yes, ma'am.
Now rotate is nothing but like a shift only. But what happened? What is the beauty of the in shift? Whatever we are this 0 will go out, so that is lost. Instead of that 0 will be placed in the carry, and whatever is come out, it will be placed in the carry flag. That will be rotated and placed here. Since 0 same thing is maintained here. Suppose 1 was come out means that 1 will be placed here. That is the difference between the rotate and shift. Same thing. See, in the shift, whatever has come out will be lost. That bit will get lost. But in rotate, that will be placed in the carrier flag and you can place it in the that particular MSP. Got it?
Okay, ma'am.
Understood or not?
Yeah, ma'am. Understood.
Anybody is having doubts still? Anybody is having doubt still? Hello? I'm asking you people for 10 minutes. I'm not going to take full class here now. For 15 minutes, you concentrate enough for me. Understood, everyone? Got it?
Yes, ma'am.
Ma'am.
Any doubt?
No, ma'am.
Asha, Gaurav, any doubt?
No,
Jayant,
ma'am.
Nibidra, Shrestha,
No, ma'am.
No doubt, ma'am.
okay. Sheetal Rao, Shweta, Venkatraj, everybody have understood, no?
Yes, ma'am.
So now we are going to see the last topic, that is very important one, that is encoding of machine instruction. I'll tell you what it is. So they will give like this: write a program that can evaluate the expression A into B plus C into D in a single accumulator processor. Assume that the processor has load, store, multiply and add instruction. So you have to write one program. So what I should do? Load A. That means whatever we are loading the value in the memory. Then multiply B. So A and B will get multiplied. Store the result. So we are storing the result. Load C. Loading the C, then multiply D. That's what they have to do. No, A into B and C into D. Multiply D and add result. Whatever we got, you have to add it with the result. Then store the result. Store the memory. Simple for program. Yeah, they won't ask much. This only very important one. Register, listen everyone. Register R1 and R2 of a computer contain the decimal value 1200, 4600. What is the effective address of the memory operand in each of the following instruction? That means you have to find the effective address. What is meant by effective address? I taught you before while taking addressing modes. What is meant by effective address? Hello? What is meant by effective address, ma? Hello? I want everyone to answer. Nibidraj? Nibidraj?
Ma'am.
What is the effective address?
Don't know.
The address in the memory from which the operand you have to fetch. That is called effective address. From where you have to fetch your operand. That is called as effective address. I taught you, I think. Yes or no? Yes or no? Hello? I taught you, no, while taking the addressing modes. To find the effective address, indirect mode, direct mode. Go. So now, if nobody is answering you, whether I wanted to you want me to continue or I'll stop. Hello? Hello?
Continue.
So load 20 of R1, 5. That means we have to find, we are already having register R1 having the value 1200. R2, they are telling 4600. You have to find the effective address for each and following instruction. So load 20 of R1, 5. That means R5. That means in that particular effective address, you have to load the value of R5. R5, it can be anything. We don't know. But first, we have to find the address of the memory in which value of R5 is to be placed. So 20 of R1. 20 of R1. What is this? 20 is called as offset. 20 R1. R1 is having address what?
1200.
1200.
So 1200 plus 20, that is 1220 is your effective address now.
The value right now, not the address. It says decimal value is 1,200 and 4,600.
No, the what they have given decimal value, no problem. That decimal value you can take it, and that is become the address now. So 1220 is the effective address where the R5 value will be stored.
Okay.
See here, suppose R5 is having some 20. So effective address, how much we got here? 1220. So in 1220, a memory location, R5 value 20 will be stored. That's all. Next, move hash 3000, R5. Which addressing mode it is? Which addressing mode? Hello? Which addressing mode?
Immediate.
Immediate. So no need of finding the effective address. So the value of 3000 will be placed in R5. It's an immediate addressing mode. No need of finding effective address. Next, store R5, 30 of R1, R2. So which addressing mode it is?
Indirect with index.
Yeah, indexed. Register index. That means two offset are there. Register index with offset. So two registers are there, R1 and R2. What is the value of R1 and R2?
1,200 and 4,600.
And what is the offset?
Offset is 30.
We have to add, that's all. All the three we have to add 5,830. In the 5,830 location, the var5 value will be, we are retrieving and placing it, whatever value in the 5,830, that we are placing it in R5. That's all. Add minus of R2, R5. Which addressing mode?
Auto decrement.
Yeah, auto decrement. What is the value of R2?
4,600.
So minus 1, that is 4,999. 4,599. Then R1 plus, subtract R1 plus, R5. That is whatever the content in the memory address R1, that we have to, that address we are adding it, that value we are taking and we are subtracting with the R5. So what is the effective the address now? R1, what is the effective the value?
1201.
That's all. In the 1201, the R5 value we have to subtract it. Any doubt? Any doubt here? Hello? Understood or not,
No.
everyone? So you are only telling now. Next, register R1 and R2. Register and R1 R2 contain the decimal value 2,900, 3,000. What is the effective address for each of the following? Load R1, 555 of R2. What is the effective address of first one? Abhishek, tell me, pa. Hello? Abhishek? Abhishek, can you tell me? Load R1, 55 R2, 55 of R2. What is the effective address here? Hello, Abhishek? Can you find the effective address? Gagan? Nibidra Shrestha? Gagan, can
Repeat
it?
once again.
Which one?
the entire equation again. Solve it.
So what we are doing here, register R1, R2 contain the decimal value 1200 and 4600. We have to find the effective address, okay, of the memory operand. How to find the effective address, that we have to do now. 20 of R1, comma R5 they have given. See, I will put it in the board. I don't know. See, 20 of, what is for this one they have given? 20, low 20 of R1, comma R5. 20 of R1, comma R5. Load. Load means we have to fetch from the memory. Load means we have to fetch from the memory. And what this one is it? Which mode it is, ma? See, addressing mode you have to be very familiar. See, R1 content, R2 content they are already given. What is the value of R1 and R2? 1200, 4600. So R1 1200, R2 4600.
Ma'am,
They
this is the
have
previous
given
sum, right, ma'am?
same thing only. You are not
Okay, ma'am.
answering, no.
No, that I had my other phone. I had some mic issues. That's why I changed my phone.
So 20 of R1, 20 of which mode it is? Which mode it is? Addressing mode. Effective address is nothing but to find out the address where your operand should be fetched. That's all effective address. Please don't ask this, repeat this one. It's very easy. Where you have to fetch your operand from the memory. So 20 of R1. Which addressing mode it is? 20 of R1, comma R5. It is a
Addressing.
which addressing mode?
Index.
Hello? Tell me, pa.
Index, ma'am.
Index. Index, yeah. So index addressing mode. How to find the index address mode effective address? So what is the offset here? 20. And what is the value of R1?
1200.
So 1200. Both will get added. That is will become 1220. It's your effective address. What the computer will do? It will go to the memory, fetch from 1220. Suppose 1220, some value is there, some 70 value is there. 75. That will be placed in R5. So R5 will be having the value 75 now. That's all. 1220 is address. Got it? Got it or not?
Yeah, ma'am.
Now tell
Yes,
me a
ma'am.
move ash 3000, R5. Which addressing mode it is?
Direct.
Direct. So no need of finding effective address. Store R5, 30 of R1, R2. That is, you have to store the value of R5 in that particular memory location. What is the memory location? Which addressing mode it is? Base with index offset. That is, 2 registers are there. If 2 registers are there, it will become a base with index. Since offset also there 30, base with index offset is used to addressing mode. Now tell me how to find. How to find 30 of R1, R2. This you understood or not?
Yeah, ma'am. We'll add 30 to the R1.
R1 comma
Then
R2.
we'll R1 comma R2.
No, how we are doing? Third, store R5 comma 30 R1 comma R2. So what we are doing here? The value of R1 and value of R2 we are taking and we are adding with 30. That will become an effective address. What is the value of R1? They have given
1200.
So 1200 is R1. R2
4600.
4600.
plus 30. 30 is a offset. Now add it.
5830.
So 5830 is your effective address. So in that 5830 memory location, we are placing the value of R5. So R5 can be anything. That value you have to take it from the R5. Suppose it is 100. That will be placed here.
This is
Got it?
base and index, ma'am.
Base with index and offset.
Okay.
So next you tell me. You tell me next. Next instruction.
And where is the result being stored?
R5, value of R5 will be placed in that particular address. Now next one, add minus of R2, be fast ma. Add minus of R2 comma minus of R2 comma R5.
Oh, 1130, ma'am.
Which one?
Add R2 comma, add minus R2 comma R5.
It is auto increment, auto decrement instruction. Effective address is nothing but content of R2 minus 1. What is the content of R2? 4600. That will
600.
become 4599. That's all. So the content of that 4599 will be added with the R5. That's all. This
What is
instruction.
R5 value, ma'am?
Anything it can be. You need not worry about that. See, simply I have taken 100, 75, simply I have taken. It can be anything. It's your wish. I have taken 100. So it's anything. It's up to you. Okay.
Yeah, ma'am.
Now subtract R1 plus comma R5. Subtract R1 plus comma R5. That is, we are taking the value from the effective address of R1 and we are subtracting from R5. So what is R1?
20, ma'am. 1200.
So 1200, we have to increment it. See, they didn't put here. You have to increment it. What is that value?
1201.
Oh, 1201. That from that, what is that value in 1201? Suppose we are having some value there. See, in 1201 memory location, some value is there 80. And R5, 90 is there. So what will happen? Subtract. Subtract. So what is the value of A? From 90, we are subtracting 80. That will become 10. 10 will be placed in R5. That's all. Got it?
Yeah, ma'am.
Any doubt? So tomorrow we'll see.
can write and you have to analyze for manually and you have to write explanation for this. Here, now I will go to the using the shift register. First one, I will go to the cyclic shift register. Here, in the cyclic shift register, you can see this in the cyclic. Here also there are four D flip-flop and serial inputs as well as serial outputs, and also they are used for the clock and shift also. Here and clock and shift also you can use the what you have to do in the with the help of this cyclic shift operation. If you can connect serial output in the serial inputs, while connecting, you can see the dash lines that is for resulting cyclic shift register. See here, there is a dot lines here. See this line. Directly you have to shift the data from serial data to serial output. That is nothing but cyclic shift register. Okay. In the cyclic shift register, you can use the, it will perform to the end-to-end operations. If you are using to the source and destination, it perform to the end-to-end operation around the by using shift operation. Suppose initial content register is 10, you can take 1011 and initial register. After shifting with the help of clock pulses, what is the output will get? It will maybe changes. You will not get the same data in 1011. How will not get the data in same? See here, for example, serial input is 1, data input is 1. When it is input is 1, clock is enabled, then you can consider as 1. And also shift is also enabled, then you can take the 1. These two you can add. What is the output will get? Suppose for example, you have to assume the result is 0, that you can see act as a, this output act as a second D flip-flop of input 0. Then when it is input is 0, clock is also disabled and shift is also disabled, then you'll get the 0. Then you have to add these three conditions. What is the output you'll get in the third place of D flip-flop? You can take, you can assume output is 1, then this output act as a third bit of D flip-flop. Then you can go to the clock is also enabled, shift is also enabled, then you have to perform the third next operation. If you are keep on changing this data in serial data and serial output also, it may be changes to the according to the what data you are assigned to the serially. After, if you are ending the generating the clock pulses or generating the transient waveform, or if you are timing analysis also, you can do with the help of what data you are given to the serial input. See here, while taking this, first I will take the 8-bit serial in and serial output shift register. Serial in, I can take the 8-bit of data. While taking the 8-bit data, I will go to the SR flip-flop, set and reset. I will do it for the set and reset. While doing this set and reset, how it is perform the 8-bit serial in and serial out shift register, we will see here. For example, you can take the first serial input is 1. First serial input is 1. What is the complementary of 1? Hello? Complementary of 1 is, we'll get the 0, correct? Then 1, 0. Set is 1, reset is 0. What is the QQ bar? Hello? Hello? See here, clock is also 1. See here, how to analyze this 8-bit serial in a shift register. Don't get confused for external examination and a lab exam also. See here, my serial input is 1. That is nothing but set is also 1. Then I'll go for the reset. That is complementary of 1 is 0. Then you can take, yeah, when set is 1, clock is also enabled. That is also will get the 1. Now you can add these two, will get the Q bar. For example, Q will get the 0, Q dash is also 1, that is indicates reset. That is reset the data. First you have to set the data. After setting, immediately you can go to the reset. Then also clock is enabled. Support again set is 1, reset will get the 0, clock will be disabled, that will get the 0. Then add this, you will get the Q dash. Same thing, you can take the 8 input for the, you can pass to the serial input. See here, clock is 0, 1, 0, 1 and S1 and S0. how it is generated to the clock periods from the timing. It depends upon the clock pulses. If they keep on changing the clock pulses, automatically it will keep on change for the set and reset operations, while serial in or serial output also. Here I will show you in the one example. See here, in 8-bit serial in and serial output. Serial in it, that is serial, it means you can take the data, you have to shift it into the first flip flop one bit at a time. I mean nothing but you have to one by one you have to shift the data bit same time in the flip flops. Okay. Next, you can also you cannot load it in the parallelly. If it is serially, they ask you have to shift to the serial only, not for parallel. Okay. Serial out means that can be only read out the last flip flop, not for the first flip flop. If you are sending the data from first flip flop, it will shift it to the second, again it will shift it to the third, and keep on shifting the data. What is the output will get for the last flip flop? That is nothing but serial out. See here, in the 4-bit parallel, and using the shift register, you can take, this is a D flip flop. You can assign the parallel data 000 or 11. If it is a 1, clock is enabled, 0, clock is disabled. What is the parallel output you get? You have to find in the 4-bit parallel. Here in the shift register also you can take the register that is implemented using the mux or demux. Here this is for the 4-bit parallel in parallel out. That is we are using the serial register. Here parallel outputs, here also parallel input. These are the serial output. These are the serial input. Also I can use this shift. Also I can use the clock enable, that you have to change the keep on changing. Is there any changes? You have to write the state diagram of state transition table for the input as well as present state and next state. Here also you can take the shift register. While shift register, if you are implementing using mux and D flip flop, you can use this is for the multiplexer. Multiplexer is nothing but you can take the multiple inputs and give the single output. That is called as multiplexer. If you are using to the what you mean by demux? Demux is nothing but you can take one input and give the multiple output. That is called as demultiplexers. Here how it is performed using to the multiplexer and demux. You can see here while using this first one. The next state, if you are using shift left or shift right, that is there is any changes, you can take the action. What action is performed? There is any data is changed or parallel or serial, or there is no changes, you have to write the shift register. Here and the timing diagram also for shift register, we have to draw the timing diagram for external. External they will not ask for the theory, just you will ask for the design a 8-bit serial in serial output register. Also you have to draw the timing diagram of shift register. Then you have to write the which is serial and parallel out for the basic block diagram. Then you have to draw the state timing diagram in the perform, how it is perform the what you are designed for the serial in and serial out, that you have to perform. See here, suppose if you are assuming the register is initially is clear, because you have to clear the data before loading the serial data. Why you have to clear? Because if any data it will be stored in the inside, if you are loading, keep on loading the data, automatically it will add it and it will display the different output. That purpose only you have to clear, and then you have to apply the serial input throughout the data. How many data you wanted to assign the data inputs, either if you assign for the 4-bit or 8-bit or 16-bit or 32-bit, depends upon your data. It will be keep on changing the timing diagram. That will be always clock will be on and off. While on and off, you can take the data input is D0, D1, D2, anything. If it is 1, then the clock is enabled and load is also enabled. Then it will start from the shifting the data from one place to another place. That is also shift is also 1. Then you can see here how to shift the register. You can do it here. In the timing diagram for shift register, the first clock pulses load into the shift register in parallelly. During the next four clock pulses, this data is available at serial output, assuming that the register initially is clear that the serial input is 0 throughout and the data inputs also 1011 during the load time. How it is load and how to draw the timing diagram you will see here. These are the shift register it will be performed. You can take the ring counter. In the ring counter is depends upon the only for clock pulses. Here clock pulses, if you press the 1, automatically it will q naught is 1, others is 0. If you press the set again, it will shifting to the places from the ring counters. Here there are d flip flop, 4 d flip flop, also there is for the clock pulses. Q0, Q1, Q2, Q3 are outputs. If it is a keep on changing the one for the clock pulses, then based on that it will generate it to the output for the Q0, Q1, Q2, Q3. In the same experiment we are using into the lab experiment, I will show you how it is perform the ring counter in the continuously for using the D flip flop. Johnson counter also is there in the lab experiment. I will show you this one. See here, in the Johnson counter, while using they are used for the any inverted feedback. Here there are three D flip flop. They connected to the clock, and the data input is short circuited to the data output. What you have to do? A 3-bit shift register with given output from the last F1 flip flop feedback into the D input of the first flip flop. Suppose if your initial state register is 0, initial values is D3 is 1. So in the first clock pulses register state to the 100. See here 00, 001, 011, 0, 11, 011, 100, 110. Last is for 11. How to shift this? We'll use the using this n-bit shift register. While using to the, you can use the logic gates. Either it may be AND gate, OR gate, or XOR gate. Depends upon the your experiment or depends upon the what operation you wanted to perform. You can use to the any logic gates. Here in the general form of, if you are using the general form in the shift register or counter, that bit beings to be shifted to the leftmost stage can be general function of the shift to the register to be rightmost stage contains. If the logic only it contains XOR gates, the counter is called as linear feedback shift register. What do you mean by linear feedback shift register? The linear feedback shift register, it is defined as when the gate logic only contains the XOR gate is called as linear feedback shift register. In the linear feedback shift register also, if there is any integer or any linear bit or shift is in the register counter, it will be generate counting cycle of the length is for the 2 to the power of n minus 1. All state is also include only for except 0 state. In the linear shift register, counters have many application including random number or random generator or encoder or decoder or linear error or error correcting codes. You have to find out the, or you can apply the in this application for the shift register. You will see here the first one, design a binary counter with the help of flip flop excitation table. Here excitation table is nothing but what flip flop is looking as per the truth table, that is reverse way, that is called as excitation table. See here in the excitation table, we are using to the flip flop, two flip flops, SR flip flop, JK flip flop, D flip flop, T flip flop. This all the truth table, it will be reverse way. That is nothing but you have to write the reverse order. Then that is called as excitation table. Here, the any flip flop inputs is presented in the independent function of transition. Also, you can use to the uh, Qn, it tends to the Qn plus 1. It comes later in the table. This derived from the flip-flop. Also, it a truth table or characteristic equation is directly from the state transition diagram. Here also you can use the binary counter also. Here for the binary counter also, by using the excitation table, you have to draw the flip-flops, or you can draw the flip-flops. One can see if the present state is 0, then SR flip-flop is also 0. When SR flip-flop is 0, huh? Hello? When the present state is 0, SR flip-flop also 0. When the SR flip-flop all 0, it does not alter to the any values for the X, or it does not alter its any value for the 0. That is nothing but you can use the don't care condition. Don't write for the 0. Why? Because if you are using to the don't care condition, it may be 0 or 1. Okay. Because of that only they are writing to the don't care condition. If you are not written the don't care condition, if you are written to the 0, it is difficult to the change to the present state and next state. Because of that only they are using to the this one. Okay. Now here if the state is 0, 0 to 1, that transition occur is SR flip-flop is 1 0, the present state is input inside. That is, while 1 and 0 transition occurs, SR is equal to 0 1, the present state is also maintained. SR is equal to 0 and SR is equal to 0 1. Vice versa you have to use for the binary counter. Here you can see in the example, one example you can note down this. Hello. Hello. You can note down one example. This example you have to note down. Hello. Hello. Note down example. Hello. Note down this example.
Yes, sir.
Hello. Note down this example past. Hello.
Yes, sir.
Note down this example.
Yeah, sir.
తీసుకున్నా ఓ పిల్ల ఓ పిల్ల ఓ పిల్ల మూత పడుచుకోట్టు పిల్ల ఓ అబ్బో ఇక్కడ పో అనిపిష్టం ఇది అనిపిష్టం ఇది ఆమెమో పుసి క్యాట్ అయింది క్యాప్ వేసుకొని
Hello. Completed.
Yes, sir.
Completed this one? Hello?
Yes, sir.
Okay, note down this your example. A flip-flop with the two inputs A and B is here. There are two inputs in the flip-flop 0, 0, 0, 1, 1, 0, 1, 1. Okay, that is the output is 0, 0. There is no change. 0, 1, it will toggle or it will be changes. 1, 0 also they changed, and 1, 1 is does not changed. That is a fixed. Okay, here what is given? Input A and B function like this. For AB is equal to 0 and 1, 1, output becomes 0 and 1 respectively. AB is equal to 0, 1 flip-flops retains the previous output, while output complements for AB is equal to 1, 0. In this, you can draw the two table. Also, you can draw the excitation table and state transition diagram of the flip-flops. See here, this is for 0, 0. 0, 0 is nothing but, again, it will get the 0, 0, 1. You can write the previous data 1, 0. It is complementary. 1, 0, you can write as 0 or 1. Sorry, see here, while taking, instead of writing the 0, you can use for the don't care condition. When the don't care condition is nothing but, you can take the 0 or 1. Okay, that is they are using the excitation table. In the same thing, you can design counter for the this what is given to the AB inputs for the 4 inputs. Here, for before designing, you can see how to design the synchronous counter, or how to design the this example. This is the simple they asked. In the based on this example, you can draw the excitation table. After the draw the this table with basic of this idea, we can go for design a asynchronous counter. In the for before designing asynchronous counter, what are the rules you have to follow? First rule, at any given time, memory is state is called as present state, and also will advance to the next state on clock pulses. Also, you have to determine by conditions on the excitation lines. Suppose if your steps if you are used in the design of the counter, you have to follow the any sequential circuit, or you have to follow the any steps of synchronous counter. What you have to follow? First, you have to specify the counter sequences. Which counter you are designing, whether it is synchronous and asynchronous. While designing the synchronous and asynchronous counter, what flip-flop you are using, whether it is SR flip-flop or JK flip-flop or D flip-flop or T flip-flop, that you have to specify which counter sequences to you have to draw the diagram. After specifying the designing, next I will go to the derive the table from the what you are written the state diagram. In the state diagram, you have to draw the two table for the present state and next state. Present state is nothing but what data input you are given to the, for example, 0, 0. What is the for the next state, for the shifting for the first place to the next place, that is depends upon the flip flop. It will be changes to the data is also depends upon the flip flop. After draw the table, then you have to go for the develop the state, or you have to synthesize. Then you have to see the timing diagram of based on the what do you return to the state diagram table. Here, while using the table also, you can use the flip flop inputs. I told you, you can use any SR or JK or D or T flip flop. Based on the flip flop, it will require to the transition table. While drawing the transition table, it is also always same for the any given flip flop. Either it may be JK or SR or D or T flip flop. After that, you can go to the, you can transfer the data from one flip flop to the another flip flop. If you are using JK flip flop, or else SR flip flop, or D or T flip flop. Based on the data transfer inputs, you have to draw the K map. Through the K map, you have to find out the how many inputs you have transfer, how many output will get the in manually also you have to verify. While making the grouping also for the K map, you can go for the, either you can make the group for the cells, either you can go for the octal or any other also, depends upon the input. You can draw the K map, and also you have to generate the cells based on the logic expression, that is for serial or parallel data inputs. After that, just you have to implement the expression with the combinational logic, or you can combine the all the flip-flops, or also you have to create your own counter also. This will be these steps, all the steps, it will be helpful for the lab experiment also. See here in the lab experiment also, they are using one experiment, design a 3-bit mod 8 synchronous counter, synchronous binary up counter, use T flip-flop, add D flip-flop. I will show in the lab also for this experiments. Here, how to perform the counter. I told you present state is 0, 0. What is the next state is 0, 0, 1. What is the next state is 0, 1, 0. Keep on changing to the present state to the next state. Here, while taking this present and next state, you have to draw the your own counter also. Hello? 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 Hello?
Yes, sir.
Hello? Next class, I will explain the same thing for the counter. Binary counter, how to draw the state diagram, how to write the table, and how to analyze, how to synthesize, and how to draw the K map. Everything I will show in the next class. Okay?
Okay, sir.
Okay, thank you.